In this video, we're going to look at solving absolute value inequalities that are greater than a certain constant. When you solve greater than absolute value inequalities, we take them apart and make two inequalities out of them, forming what's called an OR compound inequality. The OR compound inequality is similar to the AND compound inequality in that we are combining two solution sets, one from each one of the two inequalities that we create, but we're combining them in a different way. When you do ANDs, you make the intersection, which is what's common to both sets. When you make an OR, you make something called the union, which are all of the points in both sets, whether they're common to both sets or not. With the AND compound inequality, you get two sets that cross each other. So what's common is kind of the numbers that are in the middle, so to speak, of the two. When you do an OR compound inequality, you're getting the union. And with absolute value inequalities, what happens with most of the greater thans is that you get one set that goes off in one direction, another set that goes off in the other direction, and they actually do not intersect anywhere. They don't have any common points. So you have kind of a gap between the two. All right, let's take a look at an example, and I'll show you how this kind of plays out. All right, let's say that we've got the absolute value of 2x plus 7 is greater than 17, okay? So like the AND compound inequality that we created from the less than, the OR gives us two inequalities, and as I mentioned in the previous video, we can't make a three-part compound inequality out of an OR. It just doesn't work like that. The three parts can only be done with ANDs, where we have the variable expression that's common to the two. So for the OR, you split it up. We'll have 2x plus 7 is greater than 17, just like it is, except no absolute value bars. Or 2x plus 7 is less than negative 17. You change two things. You change the inequality symbol, and you change the sign of the constant, okay, before you go to solve these. So if I take this first one and solve it, I'm going to get 2x. We subtract 7 from both sides. So 2x is greater than 10. X is greater than 5. Or on the other side of this, 2x is less than, and if I subtract 7 here, I'm going to get negative 24. So x is less than negative 12. Okay, so I've got two different sets. With the intersection, it's pretty easy to put that answer together without seeing it on a graph. So you could probably go straight to the inequality notation or the interval notation if you needed to. With an OR, sometimes it's better if you see it drawn on a graph before you really have a good idea of what's going on. So let's first go through the set builder notation, just like we've been doing. Set builder is pretty easy. You still do x such that x is greater than 5 or x is less than negative 12, and you can change the order there if you want to and put the less than negative 12 first if you like. Then when we graph it, we do still have two numbers. Negative 12 is to the left, and then 5 would be to the right because negative 12 is smaller. We'll use parentheses because both of our inequality symbols are not or equal to's, okay? So I'll need a parenthesis at negative 12 and another one at 5, and my inequality for negative 12 reads x is less than negative 12, so that's all values to the left. And then x is greater than 5, which is all values to the right. So you see what's happening here. The two sets are actually kind of turned opposing each other, and we have this gap here in the middle where we don't have any points at all, okay? And so it's basically just two sets pinned together as the solution. And in interval notation, we have to make two separate intervals. Now, when you have an arrow going off to the left, that endpoint is at negative infinity. Infinite endpoints always get a parenthesis. So I've got parenthesis negative infinity. And then I go to negative 12, which also has a parenthesis because it's just less than for that one. Then we draw the union symbol, which is very simply just a big old U, capital U. we open up the second set, start it at 5, and go off to positive infinity. And again, when we have an infinity, we use the parenthesis on that end, okay? Showing that that point's not actually included in the set. So there is our interval notation for this. You basically just write two intervals with a U between them, okay? Let's look at another one. Let's see. X minus 6 inside the absolute value bars. This will do, this time we'll do the or equal to, we'll do greater than or equal to 9. Okay. Set it up the same way. We do two separate inequalities. One that just looks like the one we just did, and then another one where we shift the symbol and the sign. Solve them separately, add 6 to both sides. X is greater than or equal to 15, or X is less than or equal to -3. Set builder, X such that X is greater than or equal to 15, or X is less than or equal to -3. Graph, this time we'll use brackets, okay? -3 is on the left, 15 is on the right. Be sure you pay attention to which one needs to go where. And then we've got brackets at -3. That inequality says X is less than or equal to, so that goes to the left. And then at 15, we're greater than or equal to, so that would go to the right. You can see where our two sets are, the gap between them. And then interval notation, start at -infinity, where the arrow's going. Go to -3. The infinity gets a parenthesis just like always. The -3 gets a bracket because we have an or equal to. 15 also gets a bracket because of the or equal to. And then we go off to positive infinity with a parenthesis there. Okay, so that gives you a couple of different examples to look at there as you're working through these. These are not terribly hard to do. It's just 'cause sometimes it's hard to keep which one's which straight, okay? So if it's greater than, that's when you use an or. If it's less than, you use an and. Let's look at the special cases that we have for the greater thans, kind of like we did in the other video for the less thans. So we'll start out first with the negatives. If you have absolute value, and again I'm just going to randomly pick a little inequality to work with. Absolute value greater than a negative number. If it's greater than a negative number, well, anything that this turns into is going to be positive. That is always going to be a positive number. Positive numbers are always greater than a negative number, no matter what the negative number is. And so this is actually going to be all real numbers. You could plug any value for x in that you wanted to. And since we're doing absolute value here, that will always turn into a positive. Okay? So this is going to be all real numbers all the time. That's one way to express it, or you may also see sort of a double line R representing all real numbers. You may even see x is equal to all real numbers, something like that. Okay, there will be some way to express it. If we look at the or equal to, the situation is the same. Okay, because anything that would come out of that absolute value is going to be bigger than the negative. So it doesn't really matter that there's an or equal to on there. That's still always going to be greater than at least, okay? Because this is still always going to be positive. And a positive number is always greater than a negative. So again, the answer here is all real numbers. And I didn't write it down, but I should have. This one's greater than or equal to a negative. Okay? So So just like with the less thans, they were both no solution. Here with the greater thans, both of the symbols will give you an all real numbers answer for your result. And it's when we have it set up with 0 on one side that we get kind of mixed results. So let's those special cases with 0 this time. And we're doing greater than. Now, here's the trick with this one. What this is saying is that the absolute value needs to be bigger than 0. Well, we saw in the previous video that sometimes absolute value is equal to 0. So what you're looking at here is everywhere but that point. Okay? Let me kind of show you what I mean. If we were to solve this for 0, x plus 2 is greater than 0. So x is greater than, not greater than or equal to, greater than negative 2, okay? And we can go the other direction as well. X plus 2 is less than 0. We don't have a sign change, but we do have a symbol change, okay? So x is less than also negative 2. So it gives us one side and the other side of negative 2, but not negative 2 itself. So if we were to look at the graph of this, you would actually have negative 2 marked, and then there would be a parenthesis on either side of it bumping up next to each other like that. I know that's kind of weird looking. And what that's saying is that every single value except negative 2 is included, which is just the opposite of what happened to us when we had the absolute value less than or equal to a 0. In that instance, that one point was the only answer. Here it's the only number that's not an answer. Okay, so it's right reverse of what we saw with the less thans. In interval notation, this would look like this. Negative infinity to negative 2. Union, negative 2 to positive infinity. And what that does is it knocks the number out at negative 2. Okay, that's the only number in the whole group that's not in the solution. Now, if we do greater than or equal to 0, then we include that point as well. And so that special case is going to be all real numbers. Let's set it up just so you can see it. Okay. If we were to solve this one like we did the last one, again, you would see the two sides, okay? X is greater than or equal to negative 2. X is less than or equal to negative 2. So here's our negative 2. And we got brackets on either side. So negative 2 is actually included in that set, okay? So this, again, here is all real numbers. That's your answer. Okay, so that's if you're greater than or equal to 0. Sorry. Didn't look much better, did it? Okay. So those are your special cases. Greater than or equal to a negative will be all real numbers. Greater than or equal to 0 is all real numbers. And greater than 0 is all real numbers except the number where the inequality is equal to 0. That's the only number that's excluded. Okay? That's the end of this video.